All right, let's talk about HRW910P028. We've got, let me expand this here. Okay, we've got a wheel of radius A, and they give us the radius, is coupled by a belt B to a wheel C of radius, and they give us that radius. The angular wheel of A, or the angular speed of A, is increased from rest at a constant rate of 1.6 radians per second squared. I want to find the time needed for the wheel C to reach an angular speed of 150 revolutions per minute, assuming the belt does not slip. Okay, the main thing you need to realize about this is if they're coupled by this belt and the belt does not slip, that at any given moment the tangential speed of the edge of wheel A and the tangential speed of the wheel of the edge of wheel C has to be the same. Because since they're both attached to this belt, they both have to be basically spinning the same linear velocity at the edge. Okay, so I'm going to go ahead and write that down. Basically what I'm saying is the tangential velocity of A has to equal the tangential velocity of B at every moment of time. Okay, from the beginning to the end. So what I'm going to do is figure out how fast is the edge of wheel C spinning when we reach this angular speed of 150 revolutions per minute that we wanted to know. Okay, so let's go find out what the linear speed would be right then. I know that linear speed is angular speed times the radius. Okay, they give me the radius. They also give me angular speed, but it's in revolutions per minute. That's no good. I need that in radians per second. Okay, because eventually we're going to come back and we're going to need 1.6 anyway radians. Anyway, I need omega in standard units. Okay, so let's go ahead and let's do that first. So basically omega of C, that's going to be, I got 150 radians, or no, that's what I'm trying to figure out. Sorry, 150 revolutions per minute. Okay, well, I don't want minutes, I want seconds. So in 1 minute I've got 60 seconds. And I don't want revolutions, I want radians. So I've got 2 pi radians per revolution. So that will get rid of that. And I will have radians per second. So I pop that in a calculator and I get that the angular velocity of C is 5 pi. Now I'm going to leave pi in there for now because I'm not done with this number. And I don't want rounding error later. Okay? So now I'm ready to put that in here. So the linear speed of the edge of the wheel is 5 pi times, let's see, 20 centimeters. Okay, 20 centimeters or 0.2 meters. All right, so that gives me, well, 5 times 0.2 is just 1. So what I end up with is pi. Okay, pi meters per second. I'm glad I left pi in there. Okie dokie. Now, going back to here, if that is the linear velocity at the edge of wheel B, then that is also the linear velocity at the edge of wheel A at the time that I want to know. Okay, so I think I have to open this up. Well, let me write down some information first. So wheel A, I know at the edge is spinning pi. I also have an acceleration in radians per second squared, so I need to turn that velocity back into angular velocity so I can figure out a kinematics equation to find time. Okay, I'm just going to write down some radius so when I go full screen I can see. I don't have to go and open it. Okay, that's all I'm going to need. Alright, full screen. Okie dokie. So again, I know this, but now I'm going the other way, so I want omega So omega is going to be V over R. V is pi, and R is 15 centimeters, so 1.5 meters. Okay, so what I'm saying is wheel A started with an angular velocity of 0. It said it started from rest. And after a certain amount of time, it is going to get up to pi over 1.5, or sorry, 0.15 radians per second. Radians per second. And it has this acceleration. I want to know how much time that's going to take. So this is now a kinematics equation, and just like any kinematics equations, we write down our 6 things. Remember this? I know it's been a while. Okay. So assuming you start at theta 0. I don't know what angle I get to, and it doesn't ask me to, so I don't care. I'm going to skip that. This is 0. It gets up to this angular velocity, radians per second, and I have this angular acceleration, and I want time. That's what I want. Okay, looking at this, the only equation that works is the short equation, which is nice. Good. It's going to be this one. I want t, so if I solve this for t, I eventually get, let's see, move that to the other side, and divide by, oh, I put a. Oh dear, I'm sorry. You'd think the physics teacher would be able to keep this straight. Okay. And I have all these numbers, so all I gotta do is plug it in, and then I'll be done. So this is pi over 0.15 minus 0 all over 1.6. Pop it in the calculator, and I get 13.1 when I round it. Seconds. Let's go check that. Yes, indeedy. 13.1 seconds is the answer.